You scroll past the headline, Interstellar Comet Reappears Mid-November. Something from another star system. Sounds massive, sounds visible. You grab binoculars. You check the date. November 11th rolls around, and you step outside with your gear, and you scan the sky, and you see nothing. Not a thing. What happened? Where's the comet everyone promised? Did it vanish? Did scientists lie? Here's the thing nobody tells you. 3 words, reappears mid-November, do not mean what you think they mean. But if you're expecting a bright streak across the sky, something your kids can point at, you're about to be disappointed. The truth is harder and stranger and way more specific than the hype. This is about what visibility actually means when we're talking about an object from interstellar space. This is about magnitude scales and telescope apertures, and solar elongation, and why November matters, but not the way you think. This is about the gap between what gets clicks and what sits in the data. Let's close that gap. If you value documented astronomy and physics facts like this, subscribe. It's the best way to support our work. Also, comment from which city you're hearing this from. Also, this script is researched and factual, using sources from NASA Science official documentation published July 3, 2025, Wikipedia's 3i Atlas article, last updated 3 hours ago from today, and the SkyLives month-by-month observing guide, which tracks real-time. Ephemerides from JPL Horizons. These aren't blog posts, these are observational databases and space agency releases. Now back to the information. Atlas Telescope, Asteroid Terrestrial Impact Last Alert System, logs something moving fast through Sagittarius. Magnitude 17.5. That's 2.5 million times fainter than Polaris. The object doesn't move like anything bound to the sun. Follow-up comes within hours. Zwicky Transient Facility at Palomar. More Atlas stations. By July 2nd, the Minor Planet Center confirms it. Hyperbolic trajectory. Eccentricity 6.137. That number matters. Anything above 1 means the object isn't looping back. This thing came from somewhere else, and it's leaving. They call it 3i Atlas. The 3 because it's the 3rd interstellar object ever confirmed. The I stands for interstellar. Before this, we had 1I Oumuamua in 2017 and 2 I Borisov in 2019. 3 visits in 8 years from objects that formed around other stars. 3I Atlas wasn't even the brightest discovery. It was faint. It was far out. 4.5 billion kilometers from the sun at detection. But it was inbound. Zwicky caught it June 14th. Atlas caught it June 5th. Vera Rubin Observatory logged it earlier, but their validation phase hadn't started. The comet was crossing dense star fields in the galactic center. Hard to spot. Amateur astronomer Sam Dean digs through archives and finds more. The object had been in our sky for weeks. Nobody noticed, because it was dim and moving through the Milky Way's thickest region. The discovery delay wasn't incompetence, it was geometry. A Lowell Discovery Telescope in Arizona. All 3 spot a coma, a fuzzy halo around the nucleus, 3 arcseconds of tail-like elongation. That confirms it. Not an asteroid, a comet. David Jewett and Jane Liu used the Nordic Optical Telescope same day and report clear activity. Miguel Alarcon's team at Instituto de Astrofísica de Canarias uses the 2-meter twin telescope at Teide Observatory. They see it too. Gas and dust. The thing is outgassing even at massive distance. That's unusual. Most comets wait until they're closer to the sun. This one started sublimating volatiles at 6.4 astronomical units out. That's way beyond typical water ice activity. Something else is vaporizing. Carbon dioxide, carbon monoxide, compounds that evaporate at lower temperatures than water. Moving from Sagittarius into Ophiuchus. Hubble Space Telescope images it, July 21st, when it's 277 million miles from Earth. The image shows a teardrop-shaped coma, dust cocoon. Nucleus inside, but you can't see it directly because the coma is too thick. Hubble's tracking makes background stars streak. The comet is moving that fast, 68 kilometers per second at perihelion. That's 152,000 miles per hour, faster than 1I Oumuamua, faster than 2I Borisov, the highest speed of any interstellar object we've tracked. August rolls in. The comet brightens slowly, magnitude 15, then 14. It crosses Ophiuchus into Scorpius into Libra. Every telescope that can point at it does. James Webb. Space Telescope observes August 6th. Spherix mission detects carbon dioxide gas mid-August. Bright emission. The CO2 coma extends 3 arc minutes across the sky, but it's only visible in near infrared. Human eyes can't see it. Lowell Observatory reports tentative cyanide detection August 22nd. Very Large Telescope confirms cyanide and finds nickel August 21st. Nickel in a comet coma. That's weird. Most comets don't show nickel signatures this strong. The nickel to iron ratio is abnormal. The nickel to cyanide ratio is orders of magnitude higher than 2 I Borisov. Some researchers flag it. Avi Loeb writes about it. He calls the nickel levels unusual. Others say it's within the range for outgassing from a primordial icy body. The debate sits in preprints, no consensus yet. 1.5 times 10 to the 25 molecules per second. A week later, it's 4.5 times 10 to the 25. The outgassing is accelerating. The coma grows. July images from Gran Telescopio Canarias show a coma 26,400 by 24,700 kilometers across. That's twice Earth's diameter. SphereX finds the CO2 coma extends at least 348,000 kilometers in radius. The comet is surrounded by an invisible carbon dioxide cloud bigger than the distance between Earth and the Moon. September 15th. The dust tail measures 100,000 kilometers long, 50 arc seconds across the sky. Still faint to the eye, but growing. September 14th. Magnitude 14.2. To see a point-like star at magnitude 14, you need a telescope with an aperture of at least 200 millimeters, 8 inches. For a diffuse comet, you need 300 millimeters, 12 inches. That's a serious amateur setup or a professional instrument, not binoculars, not a department store refractor. You need a CCD camera, or you need pristine dark skies and patience, and you need to know exactly where to point. Even then, it looks like a faint smudge. One observer described it as a fuzzy star that doesn't focus. Another said it's a ghostly patch. This isn't Hale-Bopp, this isn't Neowise. This is an object most people will never see, even if they try. Predictions say magnitude 12 by late October. Optimistic forecasts say maybe magnitude 11.5 at peak. That would make it the brightest interstellar object ever observed. Still too faint for naked eye, still too faint for 70mm binoculars. But it's getting close to the sun. The geometry shifts, solar elongation drops. The angular separation between the comet and the sun in our sky shrinks. By early October, the comet sets an hour after sunset, low on the horizon. Hard to observe through atmosphere. The window narrows. The comet passes Mars, 0.19 astronomical units, 18 million miles, 29 million kilometers. ESA's ExoMars. Trace Gas Orbiter points its camera. The CASIS instrument captures images, 5-second exposures. The comet appears as a slightly fuzzy white dot, faint. 50,000 times dimmer than what the orbiter usually images. Mars Express also points its cameras. The images don't show much. The comet is too dim and too far, even for spacecraft. But the data confirms position, confirms trajectory. No deviations, gravity only. From Earth, the comet enters the zone. Solar elongation falls below safe viewing angles for most ground telescopes. ALMA radio telescope has a 15-degree elongation limit. It stops observing October 11th. The Hubble Space Telescope has a 55-degree limit. Hubble loses the comet September 14th. Won't see it again until November 23rd. James Webb has an 85-degree limit. Webb stops observing August 25th. Won't resume until December 9th. The comet is heading behind the sun from our perspective. It's not gone. It's not hiding. It's doing what every object near the sun does. It's moving through conjunction. Not with ground telescopes, not with binoculars, not with your eyes. The glare is total. Space-based instruments like GOES 19 weather satellite might catch it, but for anyone on Earth, the comet vanished from view. This is the first gap in the hype. Headlines say the comet disappears. They say it will reappear. They don't explain that disappear means geometric occlusion, not physical vanishing. The comet doesn't teleport. It doesn't hide. The sun is in the way. 203 million kilometers, 126 million miles. That's between the orbits of Earth and Mars. The comet hits maximum speed, 68 kilometers per second relative to the sun. The heating peaks, outgassing peaks, activity peaks. This is when comets brighten most. But we can't see it. Earth is on the wrong side. The comet is behind the sun. The data still flows. Mars orbiters log position. Trajectory holds. No surprises. Gravity still rules. It gets copied into articles. It gets shared. People read it, and they think the comet pops back into view like flipping a light switch. They think November 11th or 15th or whatever date they saw, and boom, the sky lights up. That's not how this works. Reappear means the solar elongation increases enough that ground telescopes can point at it without the sun in the frame. It means the comet emerges from the morning twilight before dawn. It doesn't mean sudden. It doesn't mean bright. It doesn't mean easy. The comet becomes theoretically observable again. Solar elongation climbs. The object rises about 2 hours before the sun. That's your window. 2 hours. Pre-dawn, eastern horizon, low angle, atmospheric extinction. The comet sits in Virgo, predicted magnitude around 10. Some models say magnitude 11, some say magnitude 12. The uncertainty is real because comets are unpredictable. Outgassing rates vary, dust production varies. The estimates are educated guesses. Even at magnitude 10, it's still faint. You need a telescope, you need to know where to look. You need clear skies, you need to be away from city lights, and you need to catch it before the sun rises and washes it out. The comet is near Venus and Spica, bright reference points. That helps. But the comet itself remains a dim, fuzzy patch. Magnitude estimates hover around 10 to 11. The SkyLive predicts magnitude 10 with high uncertainty. The Comet Observer's database logs observations from amateur astronomers with 8-inch and 10-inch telescopes. They report successful imaging with long exposures. CCD cameras, stacked frames, they don't report visual sightings. Even with large apertures, you're looking at a faint smudge. If you walked outside November 11th with binoculars expecting a spectacle, you saw nothing. The comet was there. You just couldn't see it. But it doesn't make the comet bright, it just tells you where to aim your telescope. The comet continues moving through Virgo into Leo. The brightness holds around magnitude 11 for the first half of the month. By November 20th, it rises 4 hours before the sun. Better observing window. Still requires a telescope, still requires patience. The object is receding from the sun now, the brightness starts to drop. November passes and the comet fades, magnitude 12 by mid-month, magnitude 13 by month's end. Magnitude drops below 12, then below 13. The predictions all said this would happen. After perihelion, the comet moves away from the sun. Less heating, less outgassing. The brightness falls. By mid-December, magnitude 14 or fainter. The window for amateur observation closes fast. Only large professional telescopes can track it now. By year's end, it's magnitude 15 or dimmer. The comet is leaving. It's on its way out of the solar system, headed back into the void. 269 million kilometers. 167 million miles. That's the closest it ever gets to us. Still almost twice the distance between Earth and the Sun. No danger, no close call. The geometry never aligned for a dramatic show. The comet came from interstellar space at a steep angle. It cut through the inner solar system fast. It passed near Mars. It looped around the Sun. It's leaving. We get one look, and it's over. It means the solar elongation increases above minimum safe angles for ground-based telescopes. It means the comet emerges from the glare of morning twilight into a narrow pre-dawn observing window. It means if you have an 8-inch or larger telescope and a CCD camera, and you know the comet's exact position in Virgo, and you wake up before dawn and you have clear skies, you might capture it as a faint, fuzzy blob on a long exposure image. That's visibility, not naked eye, not binoculars. Not a glowing tail across the sky, just a dim smudge that requires serious equipment and skill to see. Some said it accelerated non-gravitationally. Most astronomers said it's an outgassing comet fragment. Unusual but natural. 2, Borisov, looked more normal. Classic comet, coma and tail. Nobody called it alien. 3, Atlas brought a new wave. The nickel detection sparked questions. Avi Loeb wrote about possible technological origins. He listed 8 unusual features. High nickel, low water, extreme negative polarization, trajectory aligned with the WOW signal direction within 9 degrees. He called it worth investigating. Most astronomers pushed back. They said the chemistry fits an ancient comet from a carbon-rich protoplanetary disk. They said the nickel is within range for primordial volatiles, exposed to cosmic radiation for billions of years. They said polarization can vary with dust properties. They said the WOW signal alignment is coincidence. The debate sits in papers and preprints. No smoking gun either way. Hubble observations, as of August 20th, 2025, constrain the size. The nucleus is obscured by the coma, so we can't measure it directly. The object shows clear cometary activity. Coma, tail, outgassing, dust emission, hydrogen cyanide, carbon dioxide, carbon monoxide. Water vapor detected by Swift Observatory, July 30th and August 1st. Water ice confirmed by Gemini South and NASA Infrared Telescope Facility. The Sphere-X mission detects bright CO2 emission mid-August. The chemistry is unusual but not impossible for a natural comet. High carbon content. Low water ratio. 4% water by mass versus typical comets at higher percentages. That suggests formation in a colder environment. Outer regions of a distant protoplanetary disk, maybe from a star system with different chemistry than ours. Eccentricity, 6.137. That's the highest of any interstellar object. Higher than Oumuamua at 1.2, higher than Borisov at 3.4. The trajectory tilts 175 degrees to the ecliptic. That's retrograde. The The comet came from the southern celestial hemisphere, direction of Sagittarius, near the galactic center. Researchers traced the path backward. Javier Perez Couto and colleagues at Universidad de Coruña published a study October 2025. They model 4 million years of the comet's trajectory. They checked 93 close stellar encounters. None explained the comet's speed or direction. One star showed marginal influence, 70% solar mass, negligible effect. The team concludes 3I Atlas is very old, possibly 10 billion years old, maybe older than the solar system itself. Ejected from a primordial planetary disk early in galactic history, it's been drifting through interstellar space for billions of years, untouched, frozen. Now it's warming up near our sun for a brief moment before heading back out. The thin disk is where we live, younger stars. The thick disk contains stars formed when the galaxy was 3 to 10 billion years old. If 3I Atlas came from there, it could be a relic from cosmic noon, the epoch when star formation peaked. When planetary systems formed rapidly across the galaxy, this comet might carry chemistry from that era, pristine, unaltered by billions of years in the cold. That makes it valuable. That makes every observation count. ES's JUICE spacecraft passes within 64 million kilometers. November 4th, 2025. JUICE uses multiple instruments, cameras, spectrometers, particle sensors. Coordination with NASA's Europa Clipper is under consideration, twin ultraviolet spectrographs. JUICE sits close to the sun, so it uses its high-gain antenna as a heat shield. Data transmission is slow. Data from JUICE's observations won't arrive until February 2026. The delay is geometry and bandwidth, but the data is coming. JUICE gets a clean view, no atmosphere, no twilight. Just the comet and the instruments. Perseverance rover on Mars snapped photos October 4th. The comet appeared as a distant point, 27 million kilometers away, no anomalies, trajectory matched predictions. NASA's Juno spacecraft at Jupiter can't observe until March 2026. By then, the comet will pass 54 million kilometers from Jupiter. Juno might catch it, might not. The brightness will be too low by then, magnitude probably below 16, tough target even for Juno's instruments. ALMA comes back online late October. Hubble resumes November 23rd. James Webb resumes December 9th. By the time Webb can see it again, the comet will be 2 astronomical units from the Sun, magnitude 13 or fainter, still worth observing. Webb can pull spectroscopic data, even from faint targets, chemical signatures, isotope ratios, organic molecules if they exist. Every data point helps. Every spectrum adds detail. This is a one-time event. 3I Atlas will leave the solar system. It won't return. We get one pass. One chance to study material from another star's planetary system. Oumuamua's tumbling and outgassing fit a natural fragment. Borisov looked exactly like our comets. 3I Atlas shows unusual chemistry, but nothing that screams artificial. No signals, no maneuvers, no geometric structures, just a dirty snowball from another star. That's still extraordinary. That's still profound. An object formed 4 or more billion years ago in a planetary system we'll never visit. It drifted through the galaxy, it entered our solar system. We spotted it, we studied it, now it's leaving. The universe is full of these objects. Researchers estimate there's almost always one interstellar object somewhere in the solar system at any given time. Most are too faint or too far to detect. The Vera Rubin Observatory will change that. Rubin's Wide Field Survey will catch dozens, maybe hundreds. We're entering an era where interstellar visitors become routine. That's the reality of astronomical surveys. You can only analyze what you're set up to analyze. Discovery often lags observation. Archives hold treasures. Atlas found 3I Atlas because it's designed for fast-moving near-Earth objects. The comet moved fast. Atlas caught it. Luck and design. The rotation period estimates give clues about the nucleus. Raúl de la Fuente Marcos reports 16.79 hours from Gran Telescopio Canarias observations, July 2nd to 5th. Tony Santana Ross reports 16.16 hours from multi-telescope observations, July 2nd to 29th. The brightness variations decrease through July, 0.3 magnitudes early on, 0.2 magnitudes by month's end. That suggests increasing coma obscuration. The nucleus gets harder to see as activity ramps up. By perihelion, the nucleus is completely hidden. The coma dominates, the tail grows. The object becomes a classic comet visually, even if the chemistry is exotic. The green color some observers reported in other comets isn't prominent in 3I Atlas. Green comes from diatomic carbon, pairs of carbon atoms. Comet Lemon showed green in October 2025. Comet C 2022 E3 glowed green in 2023. Devil Comet 12, P Ponce Brooks turned green in 2024. 3I Atlas doesn't show strong green emission. The color is reddish from dust. Similar to 2I Borsov, the dust reflects sunlight with a reddish tint. That's typical for comets with high carbon and low water. The chemistry drives the color. Just the expected radio signature of a comet outgassing. The search continues, but expectations are low. If 3I Atlas were a probe, it would need a reason to signal. It would need a power source. It would need intention. Nothing in the data suggests any of that. The object behaves exactly like a comet. Passive, predictable, natural. Most fail because they underestimate the faintness. Expectations exceed reality. That's the core of the myth. Reappears mid-November sounds dramatic. It sounds accessible. It's neither. The comet does reappear from solar conjunction. The geometry allows observation again. But the observation requires professional or advanced amateur equipment. It requires knowledge. It requires effort. The phrase hides the complexity. The reality is harder. Also, comment from which city you're hearing this from. We're pulling from real observational data here. NASA Science Documentation, JPL Horizons Ephemerides. Wikipedia's continuously updated article on 3I Atlas with over 122 observations, logged from 31 observatories. The Skylive's live tracking. EarthSky's reporting from veteran skywatcher Bob King. ESA's mission updates. Published papers from peer-reviewed journals. This isn't speculation. This is what the telescopes and spacecraft actually saw. Now back to the information. The chemical anomalies remain the biggest question. Why so much nickel? Rohan Rahatgaonkar and Daryl Seligman detect glowing nickel vapor in the coma at extraordinary distance from the sun. Temperatures too cold for normal metal vaporization. They publish findings in space.com October 27, 2025. The nickel signature appears far from perihelion. That's unusual. Most metal emissions happen close to the sun where heating is intense. 3I Atlas shows nickel emission early. The hypothesis: sublimation of exotic ices that carry metallic compounds, or nanograin dust particles vaporizing. The exact mechanism isn't clear yet. More data needed, more modeling. But the detection is real. Multiple instruments confirm it. Very large telescope. Lowell Observatory, tentatively. The nickel is there. If water is only 4%, how can the loss rate be so high? The answer might be geometry. The coma might be layered. Water ice on the surface sublimates fast when exposed. Underneath is carbon-rich ice. The ratio is low overall, but the surface activity is high. Or the nucleus is larger than estimated, and the mass allows more water despite the low percentage. Or the measurements are sampling different parts of the coma at different times, uncertainty compounds. See what molecules emit at what frequencies. Spherex detects carbon dioxide at 3.9 microns. Bright emission, water ice, absorbs around 3 microns. Gemini South and NASA infrared. Telescope facility, confirm water ice, July 5th and 14th. The combination of absorption and emission gives composition. James Webb observes August 6th. Near-infrared spectrograph, more detail. Carbon monoxide detected. Hydroxyl ions from water. Cyanide confirmed. Nickel lines visible. Each element leaves a fingerprint. The comet's fingerprint is weird but explainable if it formed in a high carbon, low water environment. Some star systems form that way. Some protoplanetary disks are carbon rich. If 3I Atlas came from one of those systems, the chemistry makes sense. 50 arc seconds, September 15th. 100,000 kilometers long, visible in long exposure images. The tail points away from the sun. Radiation pressure and solar wind push dust outward. Classic comet behavior. The tail structure shows streamers. Asymmetry. The coma is elongated along the anti-solar direction. The dust isn't uniform. Some regions produce more. The rotation of the nucleus creates patterns. Observers capture the patterns in time-lapse. The comet rotates every 16 plus hours. The brightest regions shift. The tail shifts. The object is dynamic. Vera Rubin pre-discovery images suggested smaller. Early estimates said 12 kilometers, then 10, then under 6. Each observation refines the number. The comet could be as small as 440 meters. That's tiny, less than half a kilometer across, a giant boulder. Or it could be a few kilometers. Medium-sized comet. The coma obscures the nucleus. We won't know until the comet leaves and stops outgassing. Then we might see the bare nucleus, but by then it will be too faint and too far. We might never know the exact size. The comet came from the direction of Sagittarius. Galactic coordinates put it near the galactic center, but not from it. The trajectory inclines retrograde. The speed is extreme. Tracing back 4 million years shows no strong stellar influences. That means the comet has been in free flight for longer, maybe tens of millions of years. maybe hundreds of millions, maybe billions. The lack of recent perturbation suggests ancient ejection, a close encounter with a giant planet billions of years ago, or a stellar flyby that kicked it out. Once free, it drifted. No home, no orbit, just motion through the void. Cosmic radiation bombards the surface, micrometeorite impacts, slow changes, but the interior stays frozen, pristine. Neptune ejects comets. Every star with planets does this. The Oort cloud around our sun is full of objects barely held by gravity. Occasionally one gets nudged and falls inward. We call it a long-period comet. Other stars do the same. They eject objects into interstellar space. Those objects drift. Some enter other star systems. We call them interstellar. The process is continuous. The galaxy is full of this debris, billions of objects, maybe trillions. Ejected icy bodies and rocky fragments. Most are too small and too dark to detect. 3-eye Atlas is big enough and active enough to spot. That's why we see it. It's designed for rapid response. It's designed for one-time visitors. 3-eye Atlas came too early. Comet Interceptor isn't ready, but the mission proves the concept. Intercept interstellar objects. Study them up close, sample them if possible. That's the next step. Direct exploration. Not just remote observation, actual rendezvous. Human eyes can see magnitude 6 under dark skies, magnitude 5 in moderate light pollution, magnitude 4 in cities. The scale is logarithmic. Each step is 2.5 times brighter. Magnitude 11.5 is 6. Magnitude's fainter than the naked eye limit. That's about 250 times dimmer. 70mm binoculars reach magnitude 10 under perfect conditions. The comet is fainter than that. You need at least a 4-inch telescope, preferably 6 or 8, preferably with a camera, preferably with image stacking software. That's the minimum to detect 3-eye Atlas, even at peak. You need a clear eastern view. No hills, no buildings, no trees. You need to catch it in the narrow window between when it rises and when the sky starts to brighten. That window is 1 to 2 hours. If clouds roll in, you lose the night. If the moon is bright, it washes out the comet. If you live in a city, the light pollution kills contrast. If you don't know exactly where to look, you won't find it. The comet doesn't stand out. It blends. It hides in plain sight. The comet moves through Virgo near Venus and Spica. Venus is bright, magnitude -4. Spica is magnitude 1. Both are naked eye stars. You can use them as guides. Point your telescope at Venus, shift towards Spica. The comet sits between them. It's in the field, but it's faint. You scan. You see stars. You see faint fuzzies. Which one is the comet? You check the chart, you match the star pattern, you find it. A faint smudge, no detail, no color. Just a ghostly patch slightly larger than the background stars. That's 3-eye Atlas. That's what Reappears mid-November actually looks like. The advantage of altitude is canceled by the drop in brightness. The observation window stays hard. By mid-December, magnitude 14. By year-end, magnitude 15, or worse. The comet recedes. 2 astronomical units from the sun, 2.5, 3. The heating stops, the outgassing slows. The coma shrinks, the tail fades, the object becomes a faint point, indistinguishable from background stars without precise coordinates. The distance is 1.8 astronomical units. That's closer than the sun, but not dramatically closer. The comet isn't near us. It's on the far side of its trajectory. The geometry never favors a close pass. The orbit tilts steeply. The comet crosses our orbital plane, but not where we are. Ships passing in the night, close in cosmic terms, far in practical terms. Juno's instruments are designed for Jupiter. They're not optimized for faint, distant comets. The observation is opportunistic. If Juno gets data, great. If not, we move on. By March, the comet is on its way out, past Jupiter, headed toward interstellar space. The solar system fades behind. The sun becomes a bright star, then a dim star, then a point. The comet returns to the cold. Fact. The comet emerges from solar conjunction mid-November with a solar elongation that allows ground-based telescopes to observe it again in the pre-dawn sky at magnitude 10 to 11.5, requiring a minimum 6-inch telescope and considerable skill to detect. Myth. Everyone can see the interstellar comet. Fact. Even at peak brightness, the comet is 100 to 200 times fainter than the naked eye limit and requires dedicated equipment and dark skies. Myth. The comet disappeared and suddenly reappeared. Fact, the comet followed a predictable hyperbolic trajectory around the sun, passing through solar conjunction where geometric occlusion blocked ground observation, then emerging as predicted when the solar elongation increased above minimum safe angles for telescope observation. Myth, reappears, means it's visible again. Fact, Reappears means it's technically observable again with advanced amateur or professional equipment in specific narrow time windows under ideal conditions by observers who know exactly where to point their instruments. Reappears is astronomer shorthand. It means the object comes back into observational range. It doesn't mean bright. It doesn't mean easy. It doesn't mean accessible. The gap between technical language and public understanding creates disappointment. People expect spectacle. They get reality. Reality is dimmer. Reality is harder. Reality requires tools and knowledge, but reality is also richer. An object from another star, ancient ice from a primordial disk, chemistry that formed under different conditions than our solar system, speed that proves interstellar origin, a trajectory that will carry it back into the galaxy for another billion years. That's extraordinary. That's worth the effort, but you have to know what you're looking for. Wikipedia compiles data from 122 observations across 31 observatories. The SkyLive tracks real-time position and magnitude. EarthSky reports from experienced skywatchers. ESA coordinates multi-spacecraft observations. Peer-reviewed papers publish findings. Preprints circulate. The scientific community converges on the picture. 3. Atlas is a natural interstellar comet with unusual but explainable chemistry following a hyperbolic trajectory through the solar system with peak naked-eye invisible brightness around magnitude. 11.5 observable only, with telescopes during narrow pre-dawn windows in November and early December 2025 before fading below amateur detection limits. That's the reality. No hype, no exaggeration, just the data. They'll refine models, they'll test hypotheses. The comet's composition will become a benchmark: high carbon, low water, nickel detection, old age, thick disk origin. Future comets will be measured against it. Was 3I Atlas typical? Was it an outlier? We need more samples. The Vera Rubin Observatory will provide them, dozens of interstellar objects in the coming decade. Each one adds context. Each one tests theory. But wonder needs to be grounded in facts. The facts are these. 3I Atlas arrived from interstellar space in mid-2025. It passed perihelion October 29, 2025, at 1.36 astronomical units from the Sun. It emerged from solar conjunction in early November, visible to ground telescopes at magnitude 10 to 12 in the pre-dawn sky, requiring minimum 6 to 8 inch aperture for detection. It reached closest approach to Earth at December 19th at 1.8 astronomical units distance, still too faint for naked eye or binocular observation. It showed unusual chemistry, including high nickel and carbon dioxide with low water content, suggesting formation in a carbon-rich protoplanetary disk around a distant star billions of years ago. It poses no threat to Earth. It will leave the solar system in 2026 and return to interstellar space. We observed it, we studied it, we learned from it. That's the story. But the spectroscopic data sits in archives. The images sit in databases. The light curves sit in observation logs. Every photon captured carries information. Every wavelength measured tells a story. The story is this: the universe is full of wanderers, objects ejected from their birth systems, drifting through the void. Occasionally one passes through our neighborhood. We notice. We point our instruments. We measure. We calculate. We wonder where it came from and where it's going. And for a brief moment we share space with something profoundly alien. Not alien as in engineered. Alien as in other, from somewhere else, carrying the chemistry and history of a system we'll never see. Then it leaves, and we're alone again, until the next one arrives.